All right, so you can go ahead and do a quick check. I've already included just some of the answers for the questions. Some of these don't even have all the parts, like 11 through 14, you are also supposed to do in behavior. And obviously there are some questions that you can't see the answers for at all. So I'm going to go ahead and go through all of these on how to work them, but I wanted to give this to you so you could check and see how you were doing before you watched that part of the video. All right, so remember on these questions, you want to always make sure that you named any hidden roots, any additional roots that exist, and what the degree is to begin with. So pay attention to where the commas are. The other root here is 3 minus I because those come in conjugate pairs. So I've got a degree of 3. And then we just want to write our factors. Remember, factors are opposite of roots. So this is going to be x minus 1. Remember, I showed you that you can do kind of a shortcut, do x, and you just change all the signs. X minus 3 minus I, x minus 3 plus I when you change it between the different ones. And then we said we want to do this last one first. Get rid of any i's or square roots first. So this is where we set up the, I like to set up the box just to keep myself organized. So this is x negative 3 negative I. X negative 3 positive I, and then we're just going to multiply everything out. It's going to give me x squared minus 3x ix negative 3x positive 9 negative 3I negative xi positive 3I and then negative I squared. You should notice when you use the box the same pattern that those same 4 are going to cancel out every time. I'm going to simplify what it is I have left. So that's going to give me x squared minus 6x. Those negative 3's don't cancel, remember? And then that's plus 9 and negative I. So let's simplify that negative I squared. Use your calculator. It's going to be positive 1. So it's really going to be plus 10. And then we're just going to multiply that by x minus 1. And when you do that, all the distributive property for the x's and then the negative 1, you should end up, well, I don't have the answer there. You should end up with the answer that you saw on the first page. All right, question 2, kind of going to start in a similar place. We're going to do x minus 5 over 4. And I just lied. I need to name any additional roots. The other root here is negative 2 minus square root of 2. And do x, change signs, plus 2 minus square root of 2. X plus 2 plus square root of 2. Same place, start with my square roots. Remember, they should cancel out completely. So I'm going to set that same box up again and multiply everything I need to. X2 negative square root of 2, x2 positive square root of 2, x squared, 2x, x square root 2, 2x, 4, 2 square root 2, negative x square root 2, 2 square root, negative 2 square root 2. Then the last one is going to be negative square root of 4 or just negative whole number 2 because square root times square root is a whole number. All right, so cancel just like I said before. We're going to add those together. That's going to give me x squared plus 4x. 4 minus 2 is 2, so plus 2. And then I'm going to bring this down. Remember, when you bring this other factor down, if there's a fraction, that's bottoms up, so that would have been 4x minus 5 to begin with. And then if you'll distribute the 4 and the negative 5 to all those terms, you should get that answer that was on the first slide. All right, question 3, pretty simple. This one's nice because everything is just whole numbers. I don't even have it imaginary. This is going to be a degree of 4, so I want to make sure I end up with x to the 4th at the end, or really at the beginning of my polynomial. So I'm going to write my factors: x plus 5 over 2, x minus 2, x plus 2, x plus 1. We said the easiest place to always start is conjugates if they exist, so I noticed these right here, so I'll do those first. If I distribute, that's going to give me x squared plus 2x. Distribute the negative 2 minus 2x minus 4. If I combine like terms, that'll give me x squared, those are going to cancel, minus 4. And then I'll bring my other factors down, x plus 1. Remember, when you bring this one down bottoms up, just like I said before, 2x plus 5. And then you're just going to keep distributing one by one. So if you want to pair these together, you'll distribute the x's, and then you'll pull the x plus 1 down. That should get you to where you need to be able to find the final answer there. All right, and then this last one, question 4. Notice this has two imaginaries, but they're different. They're not conjugates of each other. So we got to list both of the conjugates. I don't know what just happened there. So on this one, we've got two roots that are missing. There's a negative I and a positive 3i. So when I go to write my factors, I'm going to pair the conjugates together. So I'm going to do x minus I, x plus I, and then do x plus 3i, x minus 3i. And then we'll multiply. Since these are conjugates, you can kind of pair those off together in the beginning. So I'm going to distribute. I'll do colors. All right, so that's going to give me x squared plus xi minus xi minus I squared. And I didn't stack those like I've been doing, but those are going to cancel there in the middle. It's going to leave me with x squared minus I squared is really plus 1 when you use your calculator. So that's my first one. On this second one, then, I'm going to distribute again. That's going to give me x squared minus 3xi plus 3xi minus 9i squared, because it's I times I. So these in the middle are going to cancel each other out. I'm left with x squared. And when you type in negative 9i squared in your calculator, you're going to get positive 9, so plus 9. All right, and now we're just down to somewhere that we can distribute again. So you're just going to distribute again, and that's where you're going to get x to the 4th plus 9x squared plus 1x squared plus 9, which is where you get the final answer, x to the 4th plus 10x squared plus 9. All right, so you should be good on that section. You just need to make sure you work carefully and slowly. Questions 5 and 6. Which of the following have a root that isn't listed? That's what I'm talking about, is like a secret root, another root that you just don't see. A, those are all real roots, so there are no conjugates there. B is missing a conjugate. 2i would be the other root there that you don't see. And C has square roots, but notice they go ahead and list both conjugates, so C, you can see all the roots that are there. On question 6, how are all roots, degree, and polynomial equations related? What I'm really asking there is, if there are 5 roots, that means the degree is going to be 5. And you're going to have x to the 5th in your equation. I just want you to realize that roots, degree, and the exponent all kind of match each other. All right, let's get into transformations, because you didn't have these answers before. So some of you found it more helpful, and you have in the past, to even list the vertex first and kind of do that. So this vertex, if I list it, is inside's opposite, outside's the same. So that means negative 3 in the x means to go left. Negative 1 in the y means to go down. And there are no multipliers there, so those are the only two transformations, left 3, down 1. Question 8, the vertex is 0, 0, so that means I'm not going left or down at all. I do see a negative on the outside and a 2/3 on the outside. Remember, we talked about, this is one that we worked outside, we talked about splitting those two apart. So the negative itself is the reflection. And since it's on the outside, we're talking about a vertical reflection. So that means we're flipping up and down, which is over the x-axis. Remember, you're shaking your head up and down on the outside. 2/3 is also going to be vertical because it's on the outside. And since it's 2/3, that's going to end up being a compression because that's less than 1. Questions 9 and 10. So notice on these questions, I'm not even really paying attention to if it's square root or cube root, because transformations are irrelevant from what their parent functions look like, really. So question 9. Now, question 9 is a little weird. You've got this division in there. So I want you to rewrite that and see that this is really y equals square root 1/4 x plus 5. Notice that x plus 5 is together. That's why I'm putting it in parentheses. And then plus 1. So if I start, like I said, I'm going to name the vertex. That's negative 5, negative 1. And then I've got this 1/4 I have to deal with. So the negative 5, negative 1, that's going to be left and down again. And then 1/4, that's on the inside. So I'm shaking my head left to right. That's horizontal. And I'm telling myself no, so I'm going to flip that. That's a 4, which means this is going to end up being a stretch because 4 is bigger than 1. And then question 10 here. On question 10, I want to, again, same thing. I'm going to write the vertex first. So this is going to be 0, 4. Notice this 4 is on the outside of the square root, not on the inside. Okay, so that's why the 4 ends up in the y spot and it stays the same. So the 0 isn't doing anything, but that 4 is telling you to shift up 4. And then this 2 on the outside is a multiplier. So multiplying by 2 on the outside is vertical because I'm shaking my head up and down. That means the same, so I'm going to do a 2 here, and that's a number bigger than 1, so again, that's going to be a stretch. All right, questions 11 through 14. So let's just look at each of these kind of independently. I think these, to me, it helps to kind of think about what the graph is on these. So this is square root. The vertex is going to be at 1, 1. And square root, there's no reflections here. So the basic square root graph looks like that. It goes up and to the right. So when I list domain, I'm going to say domain or x values greater than or equal to 1 because I'm going to go up. The range is y values greater than or equal to 1 because I'm going to go up. Well, I guess the first one should have been to the right, but that's because I'm going up. I'm getting those values from the x and the y of the vertex. And then if you think about in behavior, as x goes to positive infinity, this is going up, right? This is right and up. So this is going to be positive infinity. And this other one, there wasn't a way for me to like quickly take that out, but that one, there is no negative infinity because it doesn't go the other direction. All right, question 12. On this one, again, I'm going to start, this is square root. So that means that's the 1, 3, 5, 7, and then I'm going to name my vertex 0, 5. Square root normally looks like this, but notice on the outside, that's vertical. That's going to change the y value. So instead of it going up, it's going to go down. It's reflecting, okay? You can even think that like that's a vertical that's going to change and make you go down 3 instead of up 1 like normal. So now that we see what that graph looks like, domain is going to be x is still greater than or equal to 0 because I'm going to the right. Range is y is less than or equal to 5 because this time I'm going down. And then positive infinity, so as we go to positive infinity, we just said we're going down, so that's negative. And then there is no as we go to negative infinity because this graph is not going to the left, so that's irrelevant. All right, question 13. Now, question 13, I have just included so that you can see it. This is kind of weird to have this -3 at the beginning. Normally, you would see that out here at the end, so I'm just going to move it for myself so that it looks a little bit better. So now let's think about that graph. I've got a vertex of 4, -3, inside's opposite, outside's the same. Since this is cube root, the graph normally looks like this. It goes both directions. And there's no reflection or flipping going on here, so that's how that's going to stay. So the domain on cube root, since I go both directions, it's just all real numbers, or you can do negative infinity to positive infinity if you want. And then the range, same thing. It's going both directions, so that's all real numbers. So here the vertex is actually irrelevant. And then if you think about as x is going to the right, this is going to be going up, so that's positive infinity. As x is going to the left, so this time the graph does go to the left, it's going down, so that's negative infinity. All right, question 13. This is square root again, so we're back to square root, which doesn't go forever in both directions. I'm going to name the vertex first. The vertex is going to be 4, -4. There's a negative on the inside, so what that's going to do is reflect it horizontally. So instead of the graph going up like this, up and to the right, the graph is going to go up and to the left. It's going to flip it horizontally, okay? So now if we think about domain, x is going to be, I'm going to the left, so that's less than or equal to 4. This is left. And then the range, I'm still going to be going up, so range is going to be y is greater than or equal to -4. And that's because I'm going up. And so if I think about my directions, this is left and up. So as we go to the left, that's this bottom option now. We're going to be going up. And the graph doesn't go to the right, so that's irrelevant. Okay, questions 15 through, I think we're going to look at 15 through 17. These are just all transformation questions. So 15 is very similar in that you kind of have to rewrite where this is. So this 5 needs to move to the end. That's like a positive 5 that needs to move to the end out here. So I'm just going to write +5, move it over. Okay, so vertex is inside's opposite. That's 3, outside's the same. And then this is square root, so the pattern is 1 over 1, 3, 5, 7. That -3 on the outside, that is a vertical stretch. And since we're talking about, well, even just since it's vertical, rise over run, that's affecting my rise right here. So I'm going to multiply my rise by -3. So I'm going to start at 3, 5, 3, 5. And I'm multiplying my rise by -3. So instead of going up 1 over 1, I'm going to go down 3 over 1, down 3 over 3. And then if I had room, I'd go down 3 over 5. And that's going to be your graph. Remember, square roots have an actual starting point. They don't go the other direction. They just start wherever you place the vertex. Okay, 16, still square root. So I'm going to do the same thing. Vertex is at -1, -4. Square root is 1 over 1, 3, 5, 7. The 1/2 on the outside, that's outside, so that's affecting the vertical, which is again going to be changing this top number. That's a multiplier to the top. So I'm going to start at -1, -4. This time I'm not going to go up 1, I'm only going to go up a half, but I'm still going to run 1 hole. Up a half, run 3 holes. Up a half, run 5 holes. All right, same thing going the other direction. Oh, not going the other direction, I don't know why I said that. This is square root, so this is the only thing that you've got there. Question 17. So 17, still start with the vertex like normal, 0, 0. This time I've got cube root, which is going to change my pattern. My pattern this time is 1 over 7, and it's plus minus. It's going to go both directions. The 4, again, I didn't mean to give you so many like this, but this 4 is on the outside, which means I'm going to be changing the vertical. So I'm going to be changing this multiplier times 4. Oh, why did I say that? I'm maybe multiplying the vertical. So this is times 4, the rise part. So I'm going to start at 0, 0. I'm going to rise 4, 4, run 1. Rise 4, 2, 3, 4, run 7. And then I'll do the same thing going the other direction. Down 4, backwards 1, down 4, backwards 7. All right, so I should get a really tall looking graph. Remember, cube root, like we said, goes both directions. And then question 18. On this one, I should have changed this for you, and it will be changed for you on your test tomorrow. Notice that there's a -x and there's no parentheses. Let's rewrite this one to be y equals the cube root of -1. I'm factoring out a -1 here. X plus 4 minus 4. Okay, that's the same thing. That's equivalent. So I'm going to just start my normal place. I'm going to name my vertex, which is -4, -4. And then I've got a -1 on the inside. So cube root, let's go ahead and write our pattern. Cube root is plus minus 1 over 1, 7. So since this is on the inside, this is going to be a horizontal change, which is a change to the run. And I'm going to be multiplying the run. Now, normally you flip that, but the reciprocal of -1 is still just -1, so I'm going to multiply by -1. So that's kind of weird, a little tricky on this one. Normally you would flip it, and if it said -2, you'd make it a fraction, -1/2. If it said positive 1/3, you'd flip it and make it a whole number 3, right? So I'm going to start at -4, -4, and then rise 1, run backwards 1, rise 1, run backwards 7 if I had room. I'm going to go down 1, run 1, down 1, run forward 7. So notice that this one is different in the direction that you run to begin with. All right, so there you go. There's our graph on this one. All right, so let's look at the next few questions. These are the systems of equations that you got from the matrices. Honestly, this is just all in your calculator, so if you're getting something wrong, you're just not typing it in probably. So I'm just going to look at some things that you may have gotten incorrect. Remember on 19, you're missing the x value, so that bottom row should be 0, 1, -4, -16. On 20, you're missing, in the first row, you're missing the x, so that should be 0, -1, -2, -13. In the second row, you're missing the z, so that should be 5, -4, 0, -4. On question 21, in the middle row, you're missing the b, so that should be -6, 0, -6, -12. All All right, on question 21, remember this one is no solution, and the reason is that last row tells you that 0 equals 1, which is not true, so that's why you're going to get no solution. Notice that these weird cases, the answers don't come up like normal. You know, normally you get this like 1, 0, 0, 0, 1, 0, 0, 0, 1, where you have these ones that run diagonally for X, Y, and Z. And in this case, since it's not set up like that, you know it's going to be some type of special case because it's just not set up quite correctly. And then on question 22, on my last row, so again, we've got that weird situation where we're not having the ones that run diagonally. My last row says 0 equals 0, which is what's giving us the infinite solutions, because 0 does equal 0. That's a true thing. All right, so that's how we're getting those two special cases. All right, so this last question, remember that we're trying to do 3 variables, so 3 equations. So Billy's Restaurant ordered 200 flowers for Mother's Day. That's going to be X plus Y plus Z equals 200. You can actually use variables that make more sense. So if you don't want to use X, Y, and Z, like in this case, they're going to ask me about how many of each type later. So maybe if you use, this is carnations, roses, and daisies. If you want to use those letters, you're welcome to do that. The second equation is going to be our rates, so 575 C plus 260 R. Oh, I'm getting those backwards. All right, there we go, got that fixed. Equals the total, which is 589.50. And then the last line is going to give you, it says they mostly ordered carnations and 20 fewer roses than daisies. Okay, so to me that reads initially that I should write an equation that says 20 fewer roses than daisies. So that means roses equals daisies minus 20. So if I solve that, that's going to be, let's see, that's going to be R minus D equals negative 20. So now we can use that to set up a matrix, and we actually want to figure out how many of each type of flower was ordered. All right, when I solve that out, so I set up my matrix. Remember that this last row, there's 0 carnations there, so you're going to put a 0 in that spot, 0, 1, negative 1. When I got my answer, I've got ones running diagonally, and my last numbers are 80, 50, 70. So you just want to identify that means there are 80 carnations, because that was my first variable, 50 roses, and 10, what is that, daisies. 10, 70. And then you just kind of want to read to make sure that makes sense. So it says they ordered mostly carnations, so that works. They ordered 20 fewer roses than daisies. That works out too. So I know that answer makes sense. All right, and then question 24. Again, we want to remember that 3 variables is going to mean 3 different equations. My 3 variables this time are talking about the different colors and their values, and it gives me 3 options. So it says for $20 you can purchase a mixture. We've got 14 gold, 20 silver, and 24 bronze. So that's going to be 14G plus 20 silver plus 24 bronze. Again, you are welcome to use X, Y, and Z. I'm just trying to make more sense of this problem. All of that's going to give you $20. Or you can have this other combination, 20 gold plus 15 silver plus 19 bronze. And that's still going to be for $20. And the last one, 30 gold plus 5 silver plus 13 bronze. Again, costs $20. So there's your matrix. You're going to use your calculator to solve that and determine the monetary value of each. All right, and my calculator, when I set up my matrix and typed all of that in, I ended up getting ones diagonally, so that's good. That's what I want. 0.5, 0.35, 0.25. So that means a gold is worth, now 0.5 is not 5 cents, right? 0.5 is 50 cents. Silver is going to be worth 35 cents, and then bronze is going to be worth 25 cents. All right, so those are going to be your values there.